All right, let's get right into it. Today, we're looking at a pretty exciting new release from OpenAI called GPT-OSS-Safeguard. And honestly, it feels like a fundamental shift in how we think about AI safety. Moving away from those rigid black box systems towards something way more open, adaptable, and, most importantly, transparent. And that really is the million-dollar question, isn't it? As these models get incredibly powerful, the challenge of making sure they're used responsibly just gets more and more complex. I mean, how do you even begin to moderate content in a way that's consistent, clear, and can actually keep up with the real world? The answer to that question, well, it's at the very heart of the AI's safety dilemma. It's not just about the rules we set anymore. It's about how we enforce them. And that really comes down to the tools we've been using up until now. Okay, so this slide nails the problem perfectly. On the left, you've got your traditional classifiers. Think of them as these opaque black boxes. You train them on tons of examples, sure, but they're super rigid. You get a yes or a no, but you never really know why. And if you want to change the rules, you got to start the whole expensive retraining process all over again. But on the right, that's what developers actually need, right? A system that's flexible, transparent, and you can update it in like an instant. So this is the big conceptual leap. Instead of trying to bake this never-ending list of rules into a model, what if the model could just read your safety policy? Whatever rules you have in plain English. That is the core idea behind GPT-OSS-Safeguard. And this brings us to the real innovation here, building models that can actually reason over a set of rules, instead of just memorizing patterns from data. It's a totally new way of looking at AI safety. So what is a safety reasoning model? Well, to put it simply, it's an AI that you can hand a rulebook to, your specific safety policy, written out just like you'd explain it to a person. The model reads it, gets it, and then applies those rules to whatever content you give it. But the real magic is that it shows its work. It gives you a step-by-step chain of thought that explains exactly why it made the decision it did. And the process itself, it's incredibly straightforward. Step 1, you give it your rules. Step 2, you give it the content you want checked. Then the model thinks it through, connecting the dots between the content and your policy. And finally, you get the classification and the full explanation. No more black boxes. It's that simple. That all sounds pretty great in theory, but let's make it real. Let's walk through a practical example to see exactly how this thing works. So let's say you're running a forum for a video game, and obviously you don't want people sharing cheats or exploits. So your first input to the model is just this simple, plain language policy. That's it. Okay, now we user posts this message. Notice they don't use the word cheat or exploit, right? This is the kind of thing that could totally fool a simple keyword filter. So this is our second input for the model. And boom, here's the output. Now, two things are huge here. First, it correctly labels it as cheating_discussion. But second, and this is the important part, it gives you the reasoning. It actually understood that unlimited gold is a way of exploiting game mechanics, and it ties that directly back to your policy. This is that transparency we were talking about in action. So let's just recap the big wins here. It's totally open source, so anyone can use it and build on top of it. It's policy-driven, which means you can change your safety rules literally on the fly, no retraining needed. It's explainable by design, which gives you that crucial transparency. And because you don't need thousands of labeled examples to get started, it's super flexible for all those tricky, nuanced safety problems that are always changing. Okay, but the big question is, how well does it actually perform in the real world? Let's take a look at the data. Now, this is where things get really interesting. On OpenAI's own internal tests, where they were juggling a bunch of complex safety policies, the results were kind of surprising. So this chart shows accuracy. On the left, you've got the basic open source models. In the middle, a much larger general purpose model, GPT-5 Thinking. And all the way on the right, GPT-OSS-Safeguard. The smaller specialized Safeguard model actually outperforms the much bigger ones. This suggests that fine-tuning for the specific type of reasoning gives it a major edge. Now, if we look at a public benchmark, this one's called Toxic Chat, we see a slightly different but still really impressive story. As you'd expect, OpenAI's huge internal safety model performs the best. But check out GPT-OSS-Safeguard. It is right up there, super competitive with these massive proprietary models. The real takeaway here is you're getting almost top-tier performance in a package that's way smaller, more efficient, and completely open. But of course, no tool is a silver bullet. And OpenAI has been really open about the current limitations. For very specific, high-volume tasks, a highly trained, specialized classifier might still edge it out in accuracy. This reasoning process also takes a bit more compute power. And yeah, like any language model, it can sometimes hallucinate. Get the right answer but for the wrong reasons. And right now, it's definitely strongest in English. These are just the honest trade-offs to keep in mind. And all of this brings us to the future. Because this isn't just about dropping a new model and walking away. It's about trying to build a new, more collaborative way of doing AI safety. I think this quote from Vinay Rao at Roost, one of the key partners here, just sums it up perfectly. The whole point is to put these critical safety tools directly into the hands of the developers and organizations that actually need them. It lets the entire community study them, change them, and innovate together. And really, this is an open invitation for you to get involved. You can download the models on Hugging Face right now and start playing with them. You can join the communities that partners like Roost are building to share best practices. The whole project is designed for collaboration, giving everyone a chance to help build what comes next in open safety tools. So, as we wrap up, this is really the question to leave you with. With tools that let you define and enforce your own safety rules, with total transparency, the power to build safer AI is becoming more accessible than ever. The question isn't just what will the big AI labs do anymore, it's what will you build with this?